So, we're talking about probabilities and odds. We need to understand some basic vocabulary. When we have an experiment, a possible result of an experiment is called an outcome. And it's spelled just like it sounds. Outcome. That's the possible result of an experiment. So, if you flip a coin, the possible results, the outcomes are head or tail. When you roll a die, possible outcomes are 1, 2, 3, 4, 5, 6. Unless you're playing an RPG, and then you could have up to a D20. An event is an outcome or a collection of outcomes, okay? Such as getting a head, getting a tail, rolling a 4, rolling a 6. And the set of all possible outcomes is called the sample space. And so one of the smartest things you can do in a problem is to write out your sample space. And when you take the regions, sometimes they're going to ask you to construct a sample space. And it's really simple. All you got to do is basically list all the possible outcomes. So in example 1, it says you flip a coin and roll a number cube. How many possible outcomes are in the sample space? List the possible outcomes. So on your homework, you can either list them out directly or you can just draw the sample space. So we start with a coin. Okay, this is a 50-cent piece. What are the possible outcomes? Heads or tails. So you could start by writing that. You got 2 outcomes, heads, or tails. After you flip the coin, you're going to roll a die. What are the possible outcomes for rolling a die?
1, 2, 3, 4, 5, 6.
6 is the number of outcomes, but listing all the outcomes is 1, 2, 3, 4, 5, 6. And you put that under heads, and you put it under tails. So this would be the sample space we have here. And so if we look at this, you could either... You got 12 options. You get a heads, then a 1, heads, then a 2, heads, then a 3, heads, then a 4, heads, then a 5, heads, then a 6, tails, then a 1, tails, then a 2, tails, then a 3, tails, then a 4, tails, then a 5, tails, then a 6. How many possible outcomes are there? Yes, 12. And really all you have to do is count the endings here. Okay. Count the endings. There's 12 possible endings.
How did you get this 6?
What do you mean, how did I get the 6? How many sides on a die are there?
There's 6.
That's where I got the 6.
For the coin.
The heads and the tails is for the coin.
Okay.
This 1 through 6 is for the die. We did both of them as one experiment. Okay? Now, once we've determined our outcomes, we can determine the probability of a particular outcome. And so the probability of a particular outcome is a measure of the likelihood or chance that it will occur. And the probability of an outcome is always between 0 and 1. And it can be expressed as a fraction, a decimal, or a percent. So it has to be between 0 and 1. And if you think about it, if we're expressing this as a percent, then that means it's between 0%, which means impossible, not going to happen, right? That's like flipping a coin and getting a snake, right? Unless your coin came from, Slytherin or something, you're probably not going to get a snake, all right? Yeah, there's no snakes on our coins, right? If you grab a Mexican coin, maybe there'll be a snake on it. And then on the other side, you got 100%. You can't have more than 100% probability of something happening, because if something happens, it's 100%. Yay, it happened. You can't have more than 100% probability. How can it be more than certain that it's going to happen?
Jesus is always the answer.
Yeah. Okay. There was a 100% chance that he was going to rise again. Not more than 100% chance. It doesn't work like that.
It doesn't work.
Okay. Now, there's 2 types of probability, and really, there's probability only means one thing, but there's 2 ways of looking at it. There is theoretical probability, And then there's experimental probability. So theoretical probability is essentially this. There's two sides to a coin, right? If I flip a coin, what's the probability that I'm going to get ahead? Half. Now, if I flip the coin 50 times, how many times should I expect to get ahead? 25 out of 50. That's theoretical probability. That's what I should get in ideal circumstances. Now, if I actually sat here and flipped a coin 50 times, I might actually come up with 30 heads. That would be the experimental probability. That would be that I actually walk this out and figure out how many I actually get.
So theoretical is just knowledge.
Theoretical is what should happen. Experimental is when you actually walk it out what actually does happen. So let's look at theoretical probability in example 2. You and your friends designed t-shirts with silk screened emblems, and you are selling the t-shirts to raise money. The table shows the number of t-shirts you have in each design. So you can have a green shirt or a red shirt. Just so you know, the red shirt is probably going to die. If any of you have ever watched Star Trek, you'll get that. Mm-hmm. Then you have a possibility of a gold emblem or a silver emblem. And so the shirts that you ordered 10 green shirts with gold emblems, 8 green shirts with silver emblems, 6 red shirts with gold emblems, 6 red shirts with silver emblems. Now it says, a student chooses a t-shirt at random. What is the probability that the student chooses a red t-shirt? First of all, how many red t-shirts are there? 12. Second of all, how many total t-shirts are there? 30. So the probability of getting a red shirt is 12 out of 30. It's your desired outcome, what you want to get, out of your possible outcomes. How many different ways they can end up. So they could end up, there's 30 different shirts they could get. There's 12 that fit the description that they want.
Can you reduce that?
Yes, we'll reduce that. I'm just showing you how we get it. So we took 12 because we wanted a red shirt, and there's 12 red shirts, out of 30 because there's a total of 30 shirts. And we reduce that, what do we get?
2/5.
2/5 is our probability. Is that between 0 and 1?
Yes.
Yes. So far, so good? Okay, now suppose we have a spinner, and the spinner gets spun 20 times, and we have a table displaying our results. So we get red 5 times. We get green 9 times. We get blue 3 times, and we get yellow 3 times. And we want to know which color has an experimental probability that's the same as the theoretical probability. Now let's think about this. Theoretical probability, how many spaces are on the circle?
4.
And this is just as important. Do they all take up the same area?
Yes.
Yes. Okay? If one of them is bigger than the other, then there's going to be a higher probability that it lands in that color. Does that make sense? If half that circle was blue, then it would be a higher probability that we get blue than the other colors. But since they're all the same area, then there's all of them have a possibility of 1 out of 4. That's the theoretical probability for all the colors. Make sense? Now, if we spun 20 times, what was the experimental probability of getting a yellow?
3.
3 out of
20.
20. Okay, we spun 20 times, it's got to be 3 out of 20. It can't just be 3, because that would be a number bigger than 1. What about blue? 3 out of 20. Are either of those equal to 1 out of 4?
No.
Okay, what about green?
9 out of 20.
Is that 1 out of 4?
No.
What about red?
Yes, 5 out of
5 out of 20, which reduces to
1/4.
1/4. So red is the only one that matches the theoretical probability. So which one's higher than the theoretical probability? Green. And the other two are lower because they're smaller than 1 out of 4.
So this is taking the experimental probability and reflecting it to the theoretical.
Comparing it to the theoretical. All right. Now let's talk about something you guys are a little more familiar with. Odds.
May the odds be ever in your favor.
You never are.
Yeah.
Thanks, Cadmus.
Yeah.
Or Effie, actually. Yes, because you're all odd. All right. Now, the difference between odds and probabilities is odds can be bigger than 1 because odds take your desired outcomes over your undesired outcomes, or your favorable over your unfavorable. Okay? And so odds give it a little differently. And you can actually have odds in favor, means the odds that it will happen, or odds against, which are the odds that it won't happen. And the two are reciprocals of each other. So the odds in favor give you the number of desirable outcomes over the undesirable outcomes. And the odds against is the exact reciprocal. The undesirable outcomes over the desirable outcomes. This is where Star Wars made a mistake. I know that's hard for me to say. But in episode 5, C-3PO said that the odds of successfully navigating an asteroid field were 3,100 and something, 3,720 to 1. I think that's what it was. And so you would say 3,720 to 1. Well, if the odds of successfully navigating an asteroid field are 3,720 to 1, that's 3,720 desirable outcomes. In other words, you would successfully navigate it 3,720 times and unsuccessfully navigate it only 1 time.
Oh.
So that's actually good. Okay?
And he made it sound bad.
And he made it sound bad.
Did you
Which is
realize
typical for C-3PO. Yes, of course I realize these things. That's what happens when you watch Star Wars that many times. All right, so let's look at example 4. Example 4 refers back to our spinner. It says, find the odds against stopping on green. So odds against means we're taking unfavorable outcomes over favorable outcomes. And when we're talking about odds, we're talking about theoretical probability. We're not talking about experimental. Okay? So if we're looking at odds against, how many unfavorable outcomes are there for green on that spinner? Isaiah? 3, because there's 3 colors that are not green. Okay? Don't have to be red, don't have to be blue, don't have to be yellow, they just have to not be green. And this is where you gotta be real careful with opposites. Okay? What's the opposite of black?
White.
Wrong.
What? Oh.
Not black.
Damn.
Okay? The opposite of black is not black. Okay? So you gotta think about that when you're looking at unfavorable outcomes. If you don't want to get black, the opposite is not getting white, it's getting not black. Okay?
You were too
Alright, so what is how many favorable outcomes?
1.
Just 1, because there's only 1 green spot. So the odds against stopping on green are 3 to 1. And we can write it as 3 over 1 or 3 colon 1. Okay? Yes, I said colon in the 9th grade classroom. All of your minds just went there. And if they didn't, they did as soon as Tyler laughed.
Wait, so that would be it?
That's it. That's the odds against stopping on green.
How would you do it with the odds in favor?
The odds in favor? Remember I said reciprocal.
So it'd be
There's
one over
1 way of landing on green, 3 ways of not landing on green.
Okay.
Okay?
Do you need
So
to find-
pay attention to which odds you're finding. You don't know how many times I've graded papers and found you got the odds just backwards. Okay? Any other questions? All right.